All right, guys, in this video, I just want to talk about another property of parallelograms. And this is a theorem again, but we tend to think of it just as a property. So it says if ABCD is a parallelogram, then the diagonals bisect each other. So I've sort of drawn the result of what this would look like. What we have here is this parallelogram, and then I've actually drawn the result. So in other words, these diagonals are bisecting each other. They're splitting each other in half. And so how does that work exactly? Well, we know that because of what we talked about in the last video, we know that BC and AD are congruent. Okay, so whenever you have a parallelogram, opposite sides are congruent. And actually, AB and CD are congruent as well. But we know that those are congruent. So we also know that whenever you have a parallel line, two parallel lines cut by a transversal, so two parallel lines cut by a transversal, this angle and this angle are going to equal each other. That's called the alternate interior angle theorem, right? And so when you have alternate interior angles, when a transversal cuts two parallel lines, then those are going to be congruent. Similarly, these angles will be congruent as well. So if by ASA, okay, let me write this down here. Triangle, well, let me write it here. Triangle, let's see here. We'll call this point E. AED is congruent. AED is congruent to CEB. And this is by ASA. So therefore, BE is congruent to DE, and AE is congruent to CE. Okay, so that's what the theorem basically says. So let's look at some examples how that's applied. Let's see here. We have parallelogram ABCD. So we know that we can use this and the other properties we've talked about. So if we're trying to find x, okay, we know that these diagonals bisect each other. So that means that x is going to equal 5. That means y is going to equal 4. And we know that z is going to equal 7. So that'd be a very simple problem applying this. Now, down here we have a parallelogram, and it's slightly more complicated. We have two questions here. Number one, find x, and number two, find O, the point O. Okay, so you notice that this is kind of on a coordinate plane. Okay, so 1, -1, 2, 4, 6, 4, and 5, -1. So this is on a coordinate plane, and we need to find those two. So how are we going to do that? Well, first of all, we need to find the distance of this, and we know because it's parallel, then if we can just find the distance of BD, then half of that, okay, so if we find the distance of BD, half of that distance is going to be BO. So how can we do that? Well, let's see here. Distance formula says distance formula is root x1 minus x2 squared plus y1 minus y2 squared. All right. So that's going to equal, I want to make this my point 2. Sorry, I'll make this my point 1. So this will be point 1, and this will be point 2. Okay. So that'll just help me here. All right. So the distance equals, looks like 6 minus 1 squared plus 4 minus -1 squared. All right, which equals, looks like 5 squared plus 5 squared, so root 50. Okay, root 50, which we can reduce that to 5 root 2. 5 root 2. Okay. Now, if we want to find what x is, then All right, x is going to equal half of that. So x equals half of 5 root 2 is 5 root 2 over 2. Okay, so x is 5 root 2 over 2. So that's going to be one of our answers. All right. Now we need to find the point. We need to find the point O. So to do that, what we have to do is, if we find the midpoint of this line, okay, if we find the midpoint of this line, we can find, you know, the midpoint would give us one of the values, x or y. So if we find the x midpoint, then we'll get the x value. If we find the y midpoint, we'll get the y value. So to find the midpoint is, you have to add up both numbers. So to find, the x value, we add 5 plus 2, so the midpoint equals 2 plus 5 over 2, which is 7 over 2, which is 3/2. So that's going to be our x coordinate. So the midpoint of x is going to be that. The midpoint of y is going to equal 4 minus 1 over 2, which equals 3 over 2. Okay. I'm going to convert these because we're finding O into a decimal. Okay. So this should be the, let's see, 3.5 and 1.5. All right. So that would be how we could apply, this theorem into different problems. Thanks for watching, guys.